In this video, we're going to talk about the volume of the cylinder. And the volume of the cylinder is found by multiplying the area of the circular base by the height of the cylinder. Now, just remember that if I were to take my cylinder water bottle, and if I were to put that up to the refrigerator to fill it with water, well, what's going to happen is that the base, that circle, is going to fill up first, and then the water is going to rise to the top. So that's going to be the volume of water, or the amount of water that's going to fill up that cylinder. So that's one way I like to think of volume and in terms of the cylinder. So the volume formula is going to be the same. Area of the base, that's big B. So let's highlight that. Times the height. All right, and that big B this time is going to be that circle that I just talked about. And the circle is going to be, or the area of the circle is going to be pi r squared. So this is going to be our formula for volume of a cylinder. All right, now let's go down and talk about example number 1. It says find the exact volume of a cylinder whose diameter is 8 inches and whose height is 2 feet. Now we have to be careful here because what we're given is inches and feet. So not quite as easy as we thought. But anyway, what we can do is, and what I did, is I just turned the 2 feet into inches. So I know 2 feet, all right, is 24 inches. And that's just multiplying. All right, now I'm inches to inches, so now I can do my work. So the first thing I'm going to do is I'm going to, the diameter, which I'm writing down my given, is 18 inches. Well, if I know the diameter is 18 inches, I know the radius is 9 inches. That's important. Okay, because the volume formula for a cylinder is volume equals pi r squared times the height. So my volume is going to be pi times, sorry about that, pi times 9 squared, and that's going to be times 24. All right, so what I can do, since they didn't tell me how to leave this answer, I can leave this in terms of pi, or I can go ahead and finish up. So I'm going to go ahead and finish up this one. So it's going to be 81 pi times 24. When I put that all in my calculator, I get an answer of, let's see, I get 1944 pi, or I get 6107.25 611858. Now, something important there. I didn't round because they didn't tell me. And as we get closer to June, if the directions do not tell us to round, either leave our answer in pi or just extend out in terms of our decimal places. All right, that's just something to remember going forward, again, as we get closer to June. Let's take a look at example number 2. Example number 2 says, a cylinder has a volume of 1,470.27 cubic feet. If the height of the cylinder is 13 feet, find to the nearest inch the length of the diameter. So in this one, I'm going to take a little different approach. So I'm going to actually convert at the end. So the first thing I'm going to do is I'm going to write down my formula. So the formula is volume equals pi r squared times h. All right, so that's that area of the circle times the height, which we use again. That's the same thing as that big B times h. All right, and now I'm given the volume, so I'm going to write down 1,070.24. That's going to equal pi r squared, and I'm given 13 feet for the height. And again, I'm looking for the diameter. So if I find the radius, then easy enough, I can find the diameter. So the first thing I'm going to do is I'm going to divide both sides by 13 pi. because I'm looking for that R. Okay, so when I do that, pretty cool, I get an answer of 36 equals R squared. Again, I'm looking for R, the radius, not R squared. So I'm going to square root both sides, and R equals 6. And that would be 6 feet. Well, I know if the radius is 6 feet, then the diameter is 12 feet. And if I know the diameter is 12 feet, then I know that the diameter, when I convert that to inches, is going to be 144 inches. All right. Something important that I want to go back to in that first example, please remember that since this answer here was in inches, that this is inches cubed. Very important, inches cubed. All right, because we're dealing with volume. Okay, let's go down to Cavalieri's principle. Very important. It says if two figures have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, this may seem simple enough just out there in theory, but really it's actually pretty cool, because if I'm looking at my first rectangular prism and the base of it is a 3x2, and if I'm looking at my second one, okay, that cross section, that base cross section there is a 3x2, and they actually are the same height. So even though this second one, the second rectangular prism, is slanted, all right, the first and the second have the same height. But also, if I'm looking at the third one, which is a triangular prism, that cross section there, the area of that cross section, well, that's a triangle, so that's 6 times 2, all right, divided by 2 is the base. That's going to have the same area. So, and it also has the same height as the other two rectangular prisms. So all three of them actually have the same volume. All right, so the amount of water that can be poured in to each one of these is going to be the same. And we can state that sometimes in our proofs, we can say because of Cavalieri's principle, they're going to have the same volume. All right, now example number 2. 2 stacks of 23 quarters is shown below. One stack forms a cylinder, but the other stack does not form a cylinder because of the little mess that's there. All right, it says use Cavalieri's principle to explain why the volumes of these 2 stacks of quarters are equal. Well, pretty straightforward. You have the same amount of quarters. All right, so you have the same number of quarters. All right, so you also have equal height. It's just one is a little messy. All right, you have the same area for each quarter. Each quarter, regardless of how they stacked, have the same area. That's a little shift in the word. That was pretty cool. Okay, so since you have the same amount of quarters, equal height, and each quarter has the same area, then you must have the same volume. All right. So what I want you to do is I want you to write down some key ideas from the video. I want you to check your understanding, be careful of your dimensions. Remember that we are still dealing with volume, so your answers are going to be cubed. And remember, go Cats, go Knights.